The first step is to draw all the forces on this and then resolve any forces into x and y components. That's what you do with number 1, number 3, and number 4. Number 2 is the only one where you resolve things into parallel and perpendicular components. So there's the weight, 98 newtons. The tension is going like this. I don't know what it is in the beginning, but that's not helpful. It's not in the x or y dimension. So I need to resolve that into the y component of x and the x component of x. These two add up to give me that. So basically I'm trading this away for these two. And once I've got that, I can do a little, actually I can't do anything else at this point. Just know this is 40. I guess I could write some trig stuff. But at this point I'll start writing my equations for net force. And I'll do it in both the x and y dimensions. Bless you. And first is the y dimension. So net force in the y dimension is 0. And I know that because this is not accelerating up or down. So 10 kilograms times 0, mass times acceleration is 0. That's the net force. The other way to get the net force is to add up all the forces. And in the y dimension there's this one and there's this one. Now at this point I don't really know that this is 98, but here's how I figure it out. I know this is positive and this is negative. So Ty minus 98 is the net force. And that net force is 0. So if Ty minus 98 is 0, then Ty equals 98. So that's how I knew that was that. The next thing I'm doing here is writing the net force in the x dimension. In the x dimension there's only one force, so that's really simple. It's just Tx. And I can write the net force in a different way. I can say it's mass times acceleration. So therefore, Tx equals 10 kilograms times A. But it looks like I've got some more work to do. I have 10 kilograms times A equals 117. Well, where did that come from? Somehow I figured out Tx is 117. Once you have Ty, and you know this is a 40-degree angle, you could use trig to find Tx. And it looks like that's what I did. I said the tangent of this angle, 40, equals the opposite over the adjacent. That's 98 over Tx. And I solve for Tx. It's 117. So once I plug 117 in here, I get mass times acceleration equals the net force in the x dimension. Divide that net force by 10 and you get the acceleration. And finally, you could use trig to do this, but I use Pythagorean theorem. Once I have Tx and Ty, I can get T. It's the square root of Ty squared plus Tx squared. It's 152. Oh, a little bit about the direction. Oh, goodness. You can see Tx is to the right.